Welcome to video 2 for this unit on linear equations and linear systems. In this video, we're going to focus on strategic solving. When we have an equation in one variable, there are many different ways to solve it. We generally want to make moves that get us closer to an equation like variable equals some number. Since there are many ways to do this, it helps to choose moves that leave fewer terms or factors. A term is a part of an expression. It can be a single number, a variable, or a number and a variable that are multiplied together. For example, suppose we want to solve 9 minus 2b plus 6 equals negative 3 times the quantity b plus 5 plus 4b. What first move would you make to solve this equation? Here is a set of steps that some people like to use to solve a linear equation in one variable. First, use the distributive property so that all the expressions no longer have parentheses. Here, negative 3 times the quantity b plus 5 is now negative 3b minus 15. Next, collect like terms on each side of the equation. Here, 9 and 6 become 15 on the left side, while negative 3b and 4b become b on the right side. What would you do next to solve this equation? Some people like to add or subtract an expression so that there is a variable on just one side. Here we can add 2b to each side. So the only remaining term with a b, 3b, is on the right side. Next, add or subtract an expression so that there is just a number on the other side. Since 3b is on the right, we want just a number on the left. Adding 15 to each side leaves us with 30 on the left and 3b on the right. Lastly, multiply or divide by a number so that you have an equation that looks like variable equals some number. Since 30 is the same as 3b's, we can divide each side by 3 to reason that 10 is the same as 1b. Following these steps will always work, although it may not be the most efficient method. From lots of experience, we learn when to use different approaches as we solve equations. Sometimes we're asked to solve equations with a lot of things going on each side. For example, x minus 2 times the quantity x plus 5 equals 3 times the quantity 2x minus 20 divided by 6. This equation has variables on each side, parentheses, and even a fraction to think about. Before we start distributing, let's take a closer look at the fraction on the right side. The expression 2x minus 20 is being multiplied by 3 and divided by 6, which is the same as just dividing by 2. So we can rewrite the equation as x minus 2 times the quantity x plus 5 equals the quantity 2x minus 20 divided by 2. Now it is easier to see that all the terms on the right side are divisible by 2, which means we can rewrite the right side again as x minus 2 times the quantity x plus 5 equals x minus 10. At this point, we could do some distribution and then collect like terms on each side of the equation. Another choice would be to use the structure of the equation. Both the left and the right sides have something being subtracted from x. But if the two sides are equal, that means the something being subtracted on each side must also be equal. Thinking this way, the equation can now be rewritten with less terms as 2 times the quantity x plus 5 equals 10. Only a few steps left! But what can we tell about the solution to this problem right now? Is it positive? Negative? 0? Well, the 2 and the 5 multiplied together are 10. So this means the 2 and the x multiplied together cannot have a positive or a negative value. Another useful structure in this equation is that each of these expressions, 2 times the quantity x plus 5 and 10, are divisible by 2. So we can divide by 2 on each side, leaving us with x plus 5 equals 5. And finally, when we subtract by 5 on each side and combine like terms, the resulting equivalent equation is x equals 0. Neither positive nor negative, just as predicted. Thank you for watching video 2 of 5 for this unit on linear equations and linear systems.